Hello, Carnivorous Day 4. Here we go. To be honest, I already recorded this and then something happened technically, so I had to restart. So, forgive me if I skim over some things last minute. I'll go through this kind of quick. There's been a lot of questions, confusion on this. I'll go through this as fast as I can to make as much sense as possible. I did get a couple emails from a lot of you, so I'll answer those questions, and I'm going to use answering those questions as my lesson for tonight or today, so that you guys can make sense of this going forward, and hopefully this gets easier for you. So, first question was this one, number 6. I'll start here. This was number 19 from Brigitte. My little French girl in class. No, I will do my best for you. So I will do this one for you, Brigitte. So first of all, we have rules we must follow, such as you cannot have a 0 in the denominator, and you cannot have negative answers in the radicals, no matter what. So, looking at this, we are only following this rule. So first things first, I'm going to factor this denominator down, and they each share an x. So I'm going to factor that out first. This is x squared plus 13x plus 42. And now we're looking at this because how does this factor down? What multiplies to 42? That adds to 13. So this is x plus 7, and this is x plus 6. So I spoke to one of your peers tonight, and his questions helped me answer this. So Damon said, find out what makes the denominator 0 so that we know what it can't be. So I know my domain can be all real numbers, negative and positive numbers, but x cannot equal 0, x cannot equal negative 7 because that makes this 0, and x cannot equal negative 6. Okay? So these are the three numbers this function cannot be for the domain, because if you input either one of these numbers, that makes this bottom 0, and that makes this fraction impossible to complete an answer. So that makes that. Just so you know, you're looking for what the x cannot be to know what your domain actually is. All real numbers except these three numbers, because this makes this true. So that's that question. Now let's look at number 6. So number 6 is also from Brigitte. So this one is 3x squared minus 8x all over 2x squared minus 5x minus 3. Now, again, I only have to worry about this rule. Cannot have the denominator equal 0. I don't care what x is in the numerator, because x can equal 0, x can equal a negative number. It doesn't matter at all. So I'm going to factor this one down, and because my a and my c are both prime numbers, this is kind of easy. All right, I got negative, negative. Clearly I know I'm having a negative positive, but now you got to use your mental math to know which number goes where. What are you doing? Get out for 1 second. Come say hi. Come say hi, Mia. Come say hi. Come say hi.
Hi guys, my mom. Okay. Hi guys. Hi guys. My mommy got me a new scooter because my old one used to be mine. We bought it from Target, and I really wanted it, so now I had to give it for me.
Perfect.
And my scooter lights up, and it's a bright pink.
That's awesome.
Bye,
Mia,
Daddy students.
All right.
And bye, Mia.
Why are you saying bye to yourself? You're silly. I don't have a friend. Oh, the Mia student. Okay. So, now which one goes negative, positive? So, you're going to put negative 3 here, positive 1 here, because 2 times negative 3 is negative 6. 1 minus 6 is negative 5, and this makes the product of negative 3. Now, you got to look at these individually. I already know this one's really mental math easy. X cannot equal 3 because that makes this 0. 0 times, if I were to put 3 in place of X here, 0 times 7 is 0. Hence, this denominator is equal to 0. Can't have that happen. This one, a little more math involved. 2x plus 1 cannot equal 0. Subtract 1, subtract 1. 2x cannot equal negative 1 because we know this is not equal to 0. So x cannot equal negative 1/2. Okay? And that's all you got to worry about, the denominator rule. The next one I'm going to do for you is number 23. And this one is also, Brigitte, you're running the rule on the questions tonight because these are also Vivi's question and a few others' questions. So, 23. 8x to the third power minus 13x squared plus 9x minus 4. Plus 9x minus 4. Guess what? I have no rules to follow because I'm not inside a fraction and I'm not inside a radical. Therefore, the rules off killed a little bit. Let me turn this. That might be easier. There we go. Therefore, I have no rules to follow based on this. So your answer is all real numbers. Okay, so that means I can input any number for x. 0, negative 75, positive 143. It doesn't make what a difference I put in for x. I'm going to get an actual answer every single time. So that takes care of that. Last but not least would be number 25. Okay? Remember, domain means input. So if I have, this is kind of hard. This one was kind of tricky. F of x equals square root on top. I got 7x squared minus 31x minus 20 all over 7x squared plus 9x. Okay? So this is kind of tricky because I got to follow the rule on my top. I cannot have this produce any negative answers. And I got to follow this on the bottom because I cannot have a 0 in the denominator. So I'm going to do this one first. Okay? So I'm going to factor this one down. They both share an x. Okay? So this is 7x plus 9. So this right here says x cannot equal 0. And this one is 7x plus 9 cannot equal 0, remember. Minus 9 on both sides. 7x cannot equal negative 9. So x cannot equal negative 9 sevenths. There are my two answers. Okay, let me scroll this down a little bit. There you go. There's that. So those are the two answers for following the denominator. So as of right now, I can have all real numbers except 0 and negative 9 sevenths because both these answers make this denominator 0. Can't have that. Up here's a little trickier. Okay. Sorry for putting this one in the homework last night. I just want you guys to know, no need to factor this one down because I'm allowed to have 0 in here. I want mental math to take over on this case. All right, so in this case, when you see something like this, you just know you're bound by one rule. You cannot have a negative number underneath the radical sign because if you do, think about it. It's impossible to take the square root of a negative number because no number times itself twice will ever equal a negative number. 4 times 4 is 16, not negative 16. Negative 4 times negative 4 is 16, not negative 16, just to get that point clear. So I always just test a number and then go from there to see what makes sense. So 0 is the easiest number to always test. So if I replace x with 0, I get 0 minus 20. I'm left with a negative 20. So I know x cannot equal 0 based on just that thinking process alone. If x is 1, well, 1 squared is 1, 7 times 1 is 7, 7 minus 31 minus 20 is a negative number. So x can also not equal 1 or, for that sake, negative 1. All right. Well, if it's negative 1, actually, think about it. If it's negative 1, this is going to say negative 31 times negative 1, which is positive 31. And 31, because if this is a negative 1, I still square a negative number. I'm going to get a positive answer. So I'm going to be able to do negative 1. Okay? So let's only focus on the positive answers for now. So if x is 2, let's see if can x equal 2. Let's see. 2 squared is 4. 4 times 7 is 28. 31 times negative 31 times 4 is negative 114. Sorry, not 2. Sorry about that. 2. This is 2. This is negative 62. My apologies. This would be 28 minus 62. Still not going to work, so x cannot equal 2. Let's see if x can equal 3. Again, I'm just having us think through this rather than find one way to do every single question, because there's not. Everything is different no matter what. Just think through this, and this is not going to go on forever. We're going to find a stopping point. So, for instance, does x equal 3? Well, 7 times 3 squared is 9. 9 is 63. 63 minus 93 is still a negative number. X cannot equal 3. Yes. Come over there.
Sorry.
Look who's back by popular demand. Come over here. Come over here. Stand for right here for 1 second, okay? 1 second. 1 second. Almost done. Okay. And I'm going to keep going until I find a number that is bigger than 0 or bigger, because I can have 0 underneath here. So let's see if 4 works. Okay? Let's see if 4 can work. Alright? So 7 times 16, because 4 squared is 16. 7 times 16. Sorry. 16 times 7. We get 2, carry the 4, we get 112. Well, I already know.
Makes you don't know.
Yeah, stop for 1 second. We got 112 minus 114, which is negative. That's not going to work. X cannot equal 4. X, let's see if x can equal 5. Okay? And if you do your math, x can equal 5 because we're going to end up getting this as an answer. Okay? Watch out, man. If you're doing your math, we got, oh, my apologies. Well, 7 times 25 is going to be 150 minus 31 times 5 is 155 minus 20. I got more negative than positive, so x cannot equal 5. Let's see if x can equal 6, okay? So 36 times 7 is 252 minus 31 times 6 is 186. We're going to be in the clear there, okay? My apologies. 7 times, 1 second. This is actually, my math was off. This is 175. So x can equal 5. Another rare day of Mr. Over making mistakes. I know it doesn't happen often, but it can happen.
So I have something about water.
Mia, I'm almost done. Give me 1 second. Give me 1 second. I know. Give me 1 second. I'm gonna have you come back and talk before I leave. Just leave 1 second.
I gotta stay in here.
Just all right. Then you stay right over there. You gotta be quiet though. I'm almost done. So 1 second. I made a mistake. 7 times 25 is 175. 175 minus 55. 155 minus 20 is 175. So that would make it 0. So I now know that your domain x can. Your domain is pretty much all real numbers. We know what we're bound by here. I said that earlier, and what x cannot be there. So x cannot be any of those numbers. X cannot be. We already know 0 is not a possibility from based on this one earlier, and x can also not be equal to negative 9/7. Do not worry about function notation. I'm sorry, do worry about function notation, but interval notation. I only want you guys to express what the domain cannot be. All right, this will be good enough for now. I think I explained all that pretty good. Yeah, interval notation was a lot of questions from a lot of you guys. So just forget about worrying about how to write it correctly. Worry more about identifying what numbers can't be. Off to the side for 1 second. That is that. And then the last thing I want you guys to think about is, I believe that's it. I'm going to assign a little less work tomorrow just so you guys can really get a grasp on this, but I'm going to make the work a little easier for you. And I'll explain these specific directions inside Google Class. I hope this is working out for you guys. I'm also going to figure out a way to get a conference going with you guys for a set hour out of the day so that we don't, again, lose any steam. Given the situation, you guys can ask any questions you want during that hour and a half window that I leave open to you guys to come in, ask questions live and be in front of everybody. Again, I'm still figuring things out, so I don't know how it's going to look yet. And I hope this answers the majority of your questions. Again, domain is what can you not have as a possible input, hence domain, to make this function work. So again, you're following just these two rules. Cannot have 0 in the denominator. You cannot have negative answers in the radicals. Okay? Keep on emailing me your questions. Keep asking me anything you want. Please stop asking inappropriate questions on YouTube. Just put the questions into Google Classroom or email me separately, whatever works for you guys. Hope this is making sense. So far, it seems like it kind of is. I'm not trying to overwhelm you guys or make you guys feel anxious, but keep asking, keep talking, keep working on this. And when we get back in class by April 21st, we'll do all this again in person so that hopefully it's a lot quicker, a lot easier, and you guys are really doing a good job given our circumstances. So I'll talk to you guys soon. What do you want to say, Mia?
So, water complains to a lot of stuff, like for washing our hands.